Alright, welcome to your guided notes for section 9.3. So remember 9.3 was everything we did about saving money. So again, we're going to kind of take a look at the formulas that you've been given and how we apply them to the different problems. So keep it in mind the way the problem is read. So the first one we're going to look at is a present value formula. So notice PV standing for present value. Okay. So here we're also going to round to the nearest cents, and if you think about it, this is usually where we are going to be investing a large amount of money in order to obtain the idea behind a future goal. Okay. So for example, if Rachel needs $3,500 in 3 years to make a down payment on a new car, how much should she invest today if she only receives 1.75% interest annually and it's being compounded semi-annually? So again, we need to kind of look at the information that we've been given. So first and foremost, we have been told that we have to have $3,500, and the time that we need it is 3 years from now. Okay. We are also told our rate is 1.75%, so if we convert that to a decimal, 0.0175. And we are told that we are compounding semi-annually. So in this case, it's going to be twice. So we need to plug it in, and what do we know? Well, my present value is going to be the amount I need, so 3,500, divided by that mess of stuff. So this is 1 plus my rate, 0.0175, divided by the number of times we're compounding, which is twice, raised to the 2 times how many years. So again, we're going to put that in our calculator, and we are going to kind of work backwards. Okay. So when we're talking about working backwards, again, bear with me while I try and get my calculator into a good spot. Alright, so we're going to start in the denominator, and again, we're going to work our way out. So we've got 0.0175. We're going to divide that by 2, and we're going to hit enter. We're going to add 1 and hit enter. Remember, as long as you don't clear anything out, the last solution your calculator has will be housed as your current answer. And then we have to raise that to the 2 times 3 and hit enter. And now we're going to take that 3,500 and we're going to divide it by that answer we saved, which says that we need a present value of $3,321 and 75 cents. Okay. Alright. Annuity, again, is used to determine future values as long as regular payments are made. So we are looking at this formula here, where we are looking for future values based on the information given. Okay. So let's look at the example where it says Jeremy is starting to save money towards his retirement at the age of 27. Okay. He deposits $215 every month into his retirement account that earns 4.62%. So the first question says, how much will he have in his account if he retires at age 52? So we've got to look at some information. So first, what do we know? Well, we know that he is making a monthly payment of $215. We also know that we are compounding monthly because he's making monthly payments. His rate is 4.62%, which as a decimal is 0.0462. And then our time. Well, he wants to retire at age 52 and he is 27. So when we're looking at that, we know that he is doing this over a span of 25 years. So we need to plug in what we know. Well, the future value is what we don't know. He's making $215 each month in payments times my whole mess of stuff of 1 plus my rate 0.0462 divided by 12 raised to the 12 times 25 minus 1, and we're going to divide that by the 0.0462 over 12. So again, we can look at our calculator. Okay, I think that's a good spot. And this time we're going to start in the top and we're going to start from the inside out. So we've got 0.0462. We're going to divide that by 12 and hit enter. Then we're going to add 1. Then we're going to raise it. Remember, you have to open your parentheses here at 12 times 25 and hit enter. Then we're going to subtract 1. Now we need to multiply that by the 215, and that is our numerator value. And we are going to divide this, open a parenthesis, by 0.0462 divided by 12. And there is going to be the future value of this account. So our future value was going to be $121,013.85. Now the second question says, determine how much money Jeremy deposited into the account until his retirement and how much interest was made. So to find what you deposited means you have to take your monthly payment times your conversion to years times the number of years of your payment, or the number of years you're doing this. Okay? So for us, that's going to be your $215 per month, again, times your conversion. So this is going to be 12 months per year times the number of years. Well, we're doing this for 25 years. So this is going to give us $64,500 that Jeremy deposited into the account. Now, to find your interest, this is going to be your future value minus your deposited amount. So here my future value was 121,013 and 85 cents. I'm going to subtract out my $64,500 because that's what I paid in. And that's going to leave me with $56,513.85 in interest. So again, this part was a two-part question. So this was your first answer, this is your second answer. So you need to make sure if you have a two-part question that you are providing both of the answers that are required for that problem. Okay. The last concept that we kind of talked about was working towards a goal. So again, working towards a goal is where you're saving to make an extremely large purchase like a home or a car. The formula required is this one, so notice it's going to be slightly different than the one we used before. Where here, most of the time what we're doing is we're trying to calculate the monthly payment that you would have to make in order to reach your goal. So Michael is planning to move into an apartment and knows that he will need to purchase new furnishings. He plans to save money for 6 years so that he will have $15,000 to put towards new furnishings. If he deposits money into an account paying 4% interest, how much does he need to deposit each month in order to have the cash to pay for his purchase? So, what do we know? Well, we know that his future value needs to be $15,000, and we know that the time is going to be 6 years. We also know that his rate is going to be 4% or 0.04. So what we don't know is what his payment is. Well, if he's going to be making monthly payments, then that means he's compounding per month, so n is 12. So my payment is going to equal the $15,000 I want times 0.04 over 12. And then we're going to divide this by that whole mess of stuff. So 1 plus 0.04 over 12 raised to the 12 times 6 minus 1. So we need to find our payment. Okay. So again, if we look at the calculator, we should be able to make that payment easily. So we're going to start from the bottom and we're again going to work our way up. Okay, so we've got 0.04 divided by 12 and hit enter. We have to add 1 and hit enter. Then we're going to raise it to our power, and remember we need to open a parenthesis here. So 12 times 6, close it and hit enter. Then we need to subtract 1 away and hit enter. Now we need to look at the top. So this answer right here we're going to save in as our answer. We're going to open a parenthesis. We've got $15,000 that we are going to multiply and open a new parenthesis. 0.04 divided by 12, close both parentheses. And now we need to divide it by your answer. So we get $180, and notice it's 0.67777, so this is going to round up to be 68. So we are going to make payments of $184.68. Now the next part says, how much does he deposit over 6 years? So that's going to be the same as before. So define your deposit. is going to be the same, where we're going to take your payment value, okay? We are going to multiply that by your conversion to years, and we're going to multiply that by the number of years you are making these payments. So here, this is going to be 184.68 times 12 months to year, okay, so this was per year, times my 6 years of payments. And this is going to tell me how much was deposited into the account, which we should come up with $13,296.80. So again, how much interest is earned is going to be calculated the same way. So your interest is going to be that future value minus your deposited value. So this is going to be 15,000 minus 13,296.80. It's going to give me a total interest of $1,703.20. Okay.